Tape segment will review solving linear inequalities. I've written some steps down that you may want to follow when solving linear inequalities. They are to first eliminate denominators if there are any other than 1. Next, to remove parentheses if there are any. Then move variable terms to one side of the equation, constant terms to the other side. Then divide both sides of the inequality by the coefficient of x or your variable. One more time, eliminate denominators or fractions if there are any other than 1. Second, remove parentheses if there are any. Then move variable terms to one side of your inequality, constants to the other side. Then divide both sides by the coefficient of the variable term. There is one other thing you must remember when solving linear inequalities. That is, if you multiply or divide both sides of your inequality by a negative number, you must reverse the direction of your inequality sign. One more time, when solving an inequality, we're looking at linear inequalities on this tape segment. If you multiply or divide through by a negative number, you must reverse the direction of your inequality sign. Let's try a few examples. First, I'd like to solve 3x less than negative 6. I'd like to solve this linear inequality for x. No denominators, no parentheses. I have my variable term on the left-hand side of this inequality. I have the constant term on the right-hand side of this inequality. Now let's finish solving by dividing both sides by the coefficient of x. So we'll solve by dividing both sides by 3. We're dividing by a positive number, so we need not reverse the direction of our inequality sign. Here, if I simplify, I'll have x less than negative 6 divided by 3, or negative 2. This is my solution. Let's graph the solution to this linear inequality. Here's a number line. Here's 0. For x less than negative 2, I'll find negative 2 on my number line. Since I have strictly less than negative 2, I'll place an open circle on negative 2. I'm going to use open circle, closed circle notation here. If you use parenthesis bracket notation, whenever I put an open circle, you'll put a parenthesis. When I put a closed circle, you'll put a bracket. For strictly less than or greater than, I'll place an open circle. For less than or equal to or greater than or equal to, we'll place a closed circle. So here's negative 2. Strictly less than means an open circle, and then x less than negative 2, I'll shade to the left. Here's my solution, and here is the graph of the solution. Let's try another example. Let's look at something similar. This time, let's solve negative 3x is less than negative 6. To solve this linear inequality, we'll divide both sides by the coefficient of x, this time negative 3. So I'll divide both sides by the coefficient of x again, but this time the coefficient of x is negative 3. Since I'm dividing by a negative number, I must reverse the direction of my inequality sign. And I've circled it to remind me that it should be reversed. When I simplify, on the left-hand side I'll have x. Reverse the direction of that inequality sign is greater than negative 6 divided by negative 3, or positive 2. Here's my solution then. Let's graph this solution. X strictly greater than 2. I'll find 2 on my number line. For strictly greater than, that will be an open circle again. Greater than, I'll shade to the right. Once again, here's my solution, and here's the graph of my solution. Let's look at some more examples. Next, we want to solve 2/3 y is greater than or equal to 8. Remember the first step I gave you at the beginning of this tape segment, eliminate denominators. This time I have a denominator other than 1. I have a denominator of 3, so I'll begin by multiplying both sides of this inequality by 3. And let's see what happens. I'll multiply the left side of this inequality by 3, and don't forget you then must multiply the right side of this inequality by 3. So I'll multiply left side and right side of the inequality by 3. If I simplify the left-hand side, it reduces to 2y is greater than or equal to 8 times 3, or 24. Next, remove parentheses. I don't have any. Move variable terms to one side and constant to the other side. I already have my variable terms on the left-hand side. I have the constant 24 on the right-hand side. And now let's divide both sides by the coefficient of the variable term, which is in this time, or the variable, excuse me, which is in this case y. So I'll divide both sides by 2. I'm dividing by a positive number, so I do not change the direction of this inequality sign. Let's simplify. We'll have y is greater than or equal to 24 divided by 2, or 12. Here's my solution. Let's now graph the solution. 12 is somewhere to the right of 0 on the number line. Greater than or equal to, that would mean a closed circle. So I'll place a closed circle on 12 on the number line, and then greater than or equal to, that means I'll shade to the right. So my solution is y greater than or equal to 12, and here's the graph of the solution. Let's look at another example. Let's solve this linear inequality. 6 plus 3t less than or equal to t plus 6. Let's go through the steps. No denominators other than 1. No parentheses. So now we'll move variable terms to one side of our inequality, constant terms to the other side. I'll move my t's to the left side and my constants to the right-hand side. First, I'll subtract t from both sides of the inequality, and I'll have 6 plus 3t minus t. Remember, that's minus 1t, so 3t minus 1t is 2t less than or equal to, that's 0 plus 6, or 6. Next, let's subtract 6 from both sides of our inequality. The left-hand side, I have 0 plus 2t, or 2t is less than or equal to 0, 6 minus 6, 0. All right, now let's finish solving by dividing both sides by the coefficient of the variable. In this case, the variable is t, and the coefficient is 2. So we'll divide both sides by 2. Simplifying, we'll have t less than or equal to 0 divided by 2, or 0. Remember, I did not have to reverse the direction of the inequality sign because in this case I was dividing both sides by a positive 2. Here's the solution then, t less than or equal to 0. Let's graph the solution. Here's my number line with 0. Less than or equal to implies a closed circle on 0, and less than means we'll shade to the left. Once again, here's my solution. Here's the graph of my solution. Let's look at some more examples. Next, let's look at this linear inequality. Negative a plus 1/5 is greater than 7/2. I'd like to solve this inequality for a. Notice this inequality has fractions in it, so I have a denominator of 5 and a denominator of 2. I'm going to begin by eliminating denominators. And by the way, I'm only showing you one way of solving these linear inequalities. For many of them, there are many other ways. So let's begin by eliminating denominators, and I'll do so by multiplying both sides of this inequality by 10. All right. Multiplying the left-hand side of this inequality by 10 means multiplying every term by 10. And then the right-hand side by 10 also. Here I have 10 times negative a, and that would be negative 10a, plus 5 will go into 10 2 times, and then I have 1 times 2, or 2, is greater than, 2 will go into 10 5 times, and then notice I have 7 times 5, or 35. And now I'm solving this equivalent linear inequality. Negative 10a plus 2 is greater than 35. To solve this, I have no parentheses now, so let's move variable terms to one side and all constants to the other side. To do this, I'm going to subtract 2 from both sides of my inequality. I'll have negative 10a is greater than 35 minus 2, and 35 minus 2 would be 33. Then finish solving for a by dividing both sides by the coefficient of a, which in this case is negative 10. I'll divide both sides by negative 10. I'm dividing by a negative number. That means you must reverse the direction of the inequality sign. The left-hand side, when I simplify, I'll have a, reverse the direction of the inequality sign, and I'll have less than, and then 33 divided by negative 10. So my solution is a is less than 33 over negative 10, or negative 33 tenths, or if you'd like to turn it into a mixed number, it would be negative 3 and 3 tenths, but I'll leave it as an improper fraction. If I then graph my solution, negative 33 over 10, somewhere to the left of 0. Strictly less than, that would be an open circle. And less than, I would shade to the left. All right, here's my solution, and here's the graph of my solution. Let's look at another example. Next, I'd like to look at 3 times, in parentheses, x minus 2, close parentheses, plus 2x is greater than negative 1. Let's solve this linear inequality. No denominators other than 1, so let's remove parentheses by distributing the 3. That would be 3 times x, or 3x, minus 3 times 2, or 6, plus 2x is greater than negative 1. Now notice I have a couple of like terms I can combine, so let's do so. 3x plus 2x is 5x, so I have 5x minus 6 is greater than negative 1. Now let's move variable terms to one side, constants to the other side. To do this, I believe I'll add 6 to both sides of my inequality. If I add 6 to the left-hand side, I'll have negative 6 plus 6, or 0, so I'll have left the 5x greater than, if I add 6 to the right side, that would be negative 1 plus 6, and negative 1 plus 6 is a positive 5. Now finish solving by dividing both sides by the coefficient of x. In this case, the coefficient of x is 5. I'll have x greater than 1. So my solution is x greater than 1. Let's graph the solution on a number line. 1 to the right of 0. Strictly greater than, that means an open circle. And greater than, I'll shade, or I'll graph to the right of 1. Once again, here's my solution, and here's the graph of my solution. Let's look at this example. Negative 3 times, in parentheses, 2x minus 7 is less than negative 2 times, in parentheses, 3x plus 4. Going over the steps, 1 to eliminate denominators, if there are any other than 1. None here. Second, remove parentheses. So let's first distribute this negative 3. Negative 3 times 2x, that would be negative 6x. Negative 3 times negative 7, that's plus 21, positive 21, less than negative 2 times 3x, that's negative 6x. Negative 2 times positive 4, that's negative 8. So I have negative 6x plus 21 is less than negative 6x minus 8. All right, next let's move variable terms to one side of our inequality, constants to the other side. I'll move my variable terms to the left-hand side, although it makes no difference. I could move them to the right-hand side. To move variable terms to the left-hand side, let's add 6x to both sides of our inequality, and let's see what we have. I have 0 plus 21, which would be 21, less than 0 minus 8, which would be negative 8. Notice something different happened here. It just so happened that all of our variable terms disappeared, and we ended up with a true or false inequality. Well, my inequality reads 21 is less than negative 8. Is that true or false? 21 is not less than negative 8. That is a false statement, which means this inequality has no solution. All right, this inequality has no solution because this is a false statement. So you can write a set of brackets with nothing enclosed. You can have the null set. You can show an empty number line. It depends on what your instructor wants, but this inequality has no solution. Had I ended up with a true inequality, for instance, 21 is greater than negative 8, once again, had we ended up with a true inequality, the solution would have been all real numbers or the whole number line. But the answer here is no solution. Let's now look at another example. I'd like to show you a different kind of inequality now. We call this a compound inequality. Negative 3 is less than or equal to 4x minus 3 is less than or equal to 9 plus 3. Notice this is a compound inequality in that it has two inequality symbols. Negative 3 is less than or equal to 4x minus 3 is less than or equal to 9 plus 3. To solve this inequality, we'd like x by itself in the middle. All right, let's solve this compound inequality first by adding 3 to the left side, the middle, and to the right side. So add 3. This will be negative 3 plus 3 less than or equal to 4x minus 3 plus 3 less than or equal to, let's go ahead and write that 9 plus 3 as 12. So 9 plus 3 is 12, and then plus 3. Once again, here's my original compound inequality. Negative 3, I added 3. 4x minus 3, I added 3. 9 plus 3, which is 12, I added 3. Let's simplify and see what happens. I have 0 less than or equal to 4x less than or equal to 12 plus 3, or 15. Now to finish solving, I want the coefficient of x to be 1. To do this, I'll divide through by 4, the coefficient of x. So divide by 4, divide by 4, divide by 4. And the same rule holds here. If you multiply or divide through by a negative number, you must reverse the direction of your inequality signs. So 0 divided by 4, that's 0, less than or equal to x, less than or equal to 15/4, which I'll leave as an improper fraction. This is my solution then. Let me show you how to graph this solution. This would be all numbers greater than or equal to 0 and less than or equal to 15/4. So look at your number line. Here's 0, close circle because of the less than or equal to. Let's find 15/4 somewhere to the right of 0. Again, a closed circle on 15/4. And then once again, this would be all x, or all real numbers, greater than or equal to 0 and less than or equal to 15/4. So that would be all numbers between 0 and 15/4 and including 0 and 15/4. Here's the solution to that compound inequality, and here's the graph of the solution. Let's look at another example. I'd like to look at one more compound inequality. 1 is less than a half a minus 3 is less than 7. Once again, this is a compound inequality. You see two inequality signs. To solve this, we'd like 1a by itself in the middle of this compound inequality. Let's go through those steps I gave you at the beginning of the tape segment. Eliminate denominators. Notice I have a fraction here, or denominator here, of 2. So I'll begin by multiplying through by 2. That means each term is multiplied by 2. Now notice what happens. 2 times 1 is 2, is less than, when I simplify, I have 1a, or a, minus 3 times 2, or 6, is less than 7 times 2, or 14. So now I have 2 is less than a minus 6 is less than 14. All right, no parentheses here. Let's work on isolating the a. To do this, we'll add 6 to the left, in the middle, and to the right. All right, we'll add 6. I'll just use a different notation this time. Add 6. 6 plus 2 is 8, is less than a minus 6 plus 6, that would be a plus 0, or a, is less than 14 plus 6, or 20. So now I have 8 is less than a is less than 20, and this compound inequality is solved for a. Let's now graph the solution. This means all real numbers a greater than 8 and less than 20. So on the number line, here's 8 to the right of 0, and here's 20. I'll put open circles on 8 and 20. And the solution, or the graph of the solution, would be all numbers between 8 and 20, this time not including 8 and not including 20. So here's the solution to my compound inequality, and here's the graph of the solution. Let's look at one last example of a linear inequality. Let's solve this. Negative x minus, in parentheses, x plus 5 is greater than or equal to 4 times, in parentheses, 2x minus 1. Not a compound inequality this time, a linear inequality. All right, no fractions or no denominators other than 1. We do have parentheses, so let's remove the parentheses. This would be negative x. By removing this set of parentheses, I'd have negative x, or minus x, and then a negative times a positive, that would be minus 5. Once again, negative x minus 5, that's greater than or equal to 4 times 2x, or 8x minus 4 times 1, or 4. On the left-hand side, I've got a couple of like terms, so let's combine these two like terms. Negative x minus x, or think of it as negative 1x minus 1x, that would be negative 2x, minus 5 is greater than or equal to 8x minus 4. Then strictly out of habit, I'm going to move my x's to the left and my constants to the right. All right, to move this 8x, I'll subtract 8x from both sides of the inequality, and I'll have negative 10x minus 5 is greater than or equal to negative 4. Then I'll move this negative 5 by adding 5 to both sides of my inequality. So add 5. And I'll have negative 10x is greater than or equal to negative 4 plus 5, or positive 1. Then to finish solving for x, I'll divide both sides by the coefficient of x. I'll divide both sides by negative 10. Now I'm dividing by a negative number. That means I must reverse the direction of my inequality sign. Then when I simplify, I'll have x less than or equal to, I reverse the direction of my inequality sign, and then 1 divided by negative 10, negative 1/10. Now let's graph the solution. Negative 1/10 to the left of 0. Less than or equal to, that means a closed circle, and we'll shade to the left. Here's my solution, x less than or equal to negative 1/10, and here's the graph of my solution. Now that all these steps are familiar to you, you may want to try some examples on your own. Remember what a compound inequality is. Remember the steps I gave you that you may want to follow when solving a linear inequality. They are to eliminate denominators, remove parentheses, move variable terms to one side of your inequality, constants to the other side. Then to divide both sides by the coefficient of your variable term. Remember, if you multiply or divide both sides of your inequality by a negative number, you must reverse the direction of your inequality sign.